Dear students, we are coming to the third part of the problem is cascade realization. So, cascade means connected in series. The two transfer functions are connected in series means the overall it can be represented as cascade transfer function or cascaded system, right. How we have to represent in our overall function as a cascade form? It is very, very simple. Now, we take a factorize your the given problem. You are having a numerator and denominator, you may factorize either numerator or denominator, or you may factorize both numerator and denominator based on the given elements in the problem, right. You see the problem. Now, here we see that you are having delay elements of 2, z power minus 2. So, these are having a 2 factors. So, you have to find h1 of z and h2 of z. Just you have to factorize it. I think factorize it is in our school itself, even 5th or 6th standard itself we are doing factorizing. So, factorize, how we have to factorize? You have to multiply the two numbers, then you get the value, you check the value, and also you add both the numbers and you check the value. For example, here I am telling you the concept how to factorize correct manner. You see the denominator 1 plus 0.1 is z power minus 1 minus 0.2 into z power minus 2. Just you multiply 1 and 0.2, sorry 1 and minus 0.2, 1 and minus 0.2 means it will come minus 0.2. So, you have to find two numbers. So, you have to find two numbers, you multiply the two numbers, you get minus 0.2 and add the same number, you get plus 0.1, right. So, you find the two numbers, multiply the two numbers, you get the result is minus 0.2. Then add the same two number, you get the result is plus 0.1. So, for example, one is plus 0.5 and another one is minus 0.4. I take the two numbers, one is plus 0.5 and another one is minus 0.4. You multiply plus 0.5 and minus 0.4, you get 0.2. Minus 0.2 is the result, right. Okay. You add plus 0.5 and minus 0.4, you get plus 0.1. So, 1 plus 0.5 is at inverse. That means z is equal to 0.5. This is a factor, right. Z is equal to 0.5, z is equal to minus 0.4 are the factors. So, 1 plus 0.5 into z power minus 1, 1 minus 0.4 into z power minus 1. Then you multiply the 2 and you get the check with the denominator. This denominator values come. So, 1 is multiplied by 1, 1 you get 1 into minus 0.4 is 0.4, minus 0.4 is z inverse plus 0.5 into 1 z inverse into 1 means 0.5 z inverse, right. So, adding both the things plus 0.1 z inverse will come. Then last term is plus is minus or minus 0.5 into 0.4 is 0.2 z power minus 1 into z power minus is z power minus. So, it is minus 0.2 z power minus 2. So, once you are having your factors are correct or wrong, you are having doubt, just you multiply both the factors, you get our original equation, right. This polynomial, original polynomial is coming or not, please you check that, right. The small there is 1 plus 0.1 z power minus 1 minus 0.2 z power minus 2. The small equation is given to you, right. You factorize it and check whether your factorization is right or wrong by multiplying the two factors. Okay. So, as like the numerator. Now, it is you are having a in calculator itself you get an answer. Do not worry for that, right. Okay. No need to do the complex calculations. Just now everyone is having a scientific calculator. Please use your scientific calculator and to pass the values. You take 2 degrees of freedom because z power minus 2 is there. 2 degrees means it will ask the constant value, then the coefficient of z power minus 1 and z power minus 2. So, you have to pass 1 and 0.1 is the coefficient of z power minus, then minus 0.2. You pass the values means it will automatically give the values is plus 0.5 and minus 0.4. Your calculator may give automatically. So, please utilize your calculator and find the values. You no need to panic or worry about that, or it may be only minimum values are given. Only simple values are given to you because the examiners also know that you are able to solve only simple problems. They won't give any complex value. So, just small values are there, just you check it by multiplication. As I already told, numerator is also the same thing. You take two factors. here numerator 3 plus 3.6 into z power minus 1 plus 0.6 into z power minus 2. So here you see that one factor is 1 plus z power minus 1, the z is equal to minus 1, one factor. Then another factor is z is equal to minus 0.6 by 3, that is another factor. So that is 3 plus 0.6 z inverse and 1 plus z inverse is given us, or you are having doubt, you multiply both the things. 3 into 1 is 3, 3 into z inverse is 3 z inverse plus 0.6 z inverse 1 is 0.6 z inverse. So 3 plus 0.6 z inverse becomes 3.6 z inverse. Then last term is plus into plus plus 0.6 into z power minus 2. So both are right. Now it is called as h1 of z and it is called as h2 of z. Now dear students, you understand that now cascade representation is also parallel form 2, sorry, direct form 2 representation only. Cascade means it is nothing other than direct form 2 is the best representation. So cascade form as well as parallel form, just we are doing only direct form 2 representation. Whatever thing we studied in direct form 2, that can be useful for your realization. Only thing is you have to factorize it, it is h1 of z and h2 of z. This is your h of z. Your h of z is called as h1 of z into h2 of z. So once you got it, then it is over, then you are easily implement your thing in direct form 2 only. So I am draw the cascade realization, it is nothing but direct form 2. Here you see that one delay, here also one delay. So one delay in the central part or in center, in the initial side you put plus, output side is also you put plus. In the center you put only one delay, because only one delay element is the maximum, so one delay element is L of. Okay. Then as usual direct form 2, what we say is input is in this, input is in output side, output values are in input side. So 3 is here, 0.66 here, 0.6 into z inverse is here, over. In the denominator 1 plus 0.5, so here it is 1, the feedback is minus 0.5. Because of here plus 0.5 means you put it as a minus 0.5, right. Okay, this is x of z or x of n. Okay. So h1 of z implementation is over. Now you follow the same to the next transfer function h2 of z. It can be also implemented in direct form 2. Okay. So input side 1 plus, output side 1 plus, center side 1 delay element, because here also only one delay element is there. Output is y of z. In time domain it is called y of n, right. So you see that numerator is 1 plus z inverse. So 1, here also you put 1, 1 plus 1 is z inverse. Denominator you see 1, feedback minus 0.4 means it is plus 0.4. Then the multiplication is just joining these two transfer function. This is h1 of z and this is h2 of z. So both can be joined. Now it is over. So that's all about the cascade representation. So dear students, the last method is parallel form realization. So parallel form means the filters are realized, or you fix the transfer function as h1 of z plus h2 of z. So h of z can be represented as c plus h1 of z plus h2 of z. So c is a constant, it may come or it won't come. It depends upon the transfer function or the system what is given to you. Okay, based on the given system, either c may come or it may not come. So h1 of z plus h2 of z. This is our implementation, practical implementation, but the implementation is here also direct form 2 only, right. So what you do? The given transfer function is like that. So you take first partial fraction. I think even your plus 1 plus 2 studied about partial fraction, and engineering college first year also studied partial fraction. So I won't repeat again how to take the partial fraction. So you take, I think your max faculty member told that both, you see the numerator power and the denominator power, both powers are equal. You put one constant plus a by first factor plus b by second factor, right? So as like that, I already know that the factors, the denominator is having two factors, one is 1 plus 0.5 z inverse and another one is 1 minus 0.4 z inverse are the two factors. So as like the factorization formulas are there, right? You see the numerator power and denominator power. Numerator power is less means you started a by first factor plus b by second factor. Numerator power and denominator powers are equal means you say one constant, you introduce one constant plus a by first factor plus c by plus b by second factor plus c by third factor, etc. And numerator is greater, denominator is lesser means that time you put a z inverse plus b, a z inverse plus b. Maybe in your school time you put ax plus b also. So a z inverse plus b plus c by first factor plus d by second factor. So only these are the three combinations are available in the world. So no other combinations should be there. So either numerator is less than the denominator, or numerator and denominator powers are equal and numerator power is greater than the denominator power, right? Maximum numerator power and denominator power, numerator power is lesser than the denominator power, or numerator and denominator powers are equal, right? That type of combination is maximum we expect as per the that is test procedure for you. Okay, right. Now I think you understand that. So a, b are the constants. You find the values of the constant and a and b. So you find a, b, c, three constants. You find the values a, b, c by using the partial fraction. We got a is minus 3, b is 7 and c is minus 1, like that. So now is everything is okay. Now fine, we have to h1 of z is, this is c, this is h1 of z and this is h2 of z, right? Okay. Now we are going to implement it again direct form 2 only, right? You take it, I take this one. Okay. So this is the direct form. Here you see that only one delay element 0.4 into z power minus 1 is there. So I am take it as numerator only 7. Okay, 7, fine. Denominator 1 minus 0.4 means here it is plus 0.4 and it is given to this. Okay, fine. This is my x of z. So h1 of z is implemented. Then h2 of z. h2 of z is also implement, but it is a parallel. So you take it as a parallel. I draw the parallel thing. Also like the same h1 of z, we put that, right, the same transfer function, but it is in the form of parallel, right? Okay. Here you see that the numerator is having minus 1. See the numerator, and denominator you see it is 1 plus 0.5 becomes minus 0.5. Okay. Now parallel, how it is proved parallel? From the x of z should be the same for this also. Input is same for both the transfer function. So it is called as a parallel. And another one term minus 3 is there, that also we have to complete. This is minus 3. Okay. Finally you put these orders are there. So I put these two orders and this is called as my y of z, or this is y of. You may either put y of z x of z, or you may put y of n x of. Both are should be the same, right? Now you see that this is the parallel structure, parallel form realization. But really we implemented all the things in direct form 2 only. So dear students, these are the things. It is, I think it is very much clearly explained to you. Okay. If you are having any doubts, please you put your comments. Okay, thank you.